Hi, and welcome back. Today we're going to finish off our study of metals by looking how we use metals, their different reactivities and the ways that we manipulate those for different purposes and make metals fit for purpose in terms of what we want to use in and around our society. As we mentioned when we were looking at the periodic table, metal reactivity can alter. Many different metals have different properties where we see a large variation. This includes reactivity. It's often defined by the reaction with water, so a metal is defined by how reactive it is with water, but can also be determined through the reaction with oxygen and acids. So you may remember we mentioned that sodium and the group 1 metals will react violently with water, whereas we know that things like iron will rust and oxidize in air. So when we look at the periodic table, we see that reactivity of metals follows periodic trends along with metallic character because they're quite interchangeable. And you may remember that in period 3, we said that metal reactivity decreases as we go from left to right. And this is because we have our alkali and alkali earth metals over in group 1, and then we move slowly towards actual non-metals over on the far side of the periodic table. So it makes sense that as we move towards the non-metal elements, we see a decrease in reactivity. And remember that as we go down a group, so say our group 1, metal reactivity will actually increase. So group 1 and 2 metals are known as the alkali metals and the alkali earth. Group 1 reacts with water to produce hydrogen gas and a metal hydroxide. So generally what we will see happen with that is that the metal will fizz, create hydrogen gas. The heat of that reaction will then cause the hydrogen to ignite, and we'll start to see flame, and then that causes the water to boil, and we'll sometimes see an explosion. It's highly exothermic, which means it gives off a lot of energy, and it occurs very quickly. Group 2 metals will also react with water, however, they tend to be a bit slower and require more energy to get started. Transition metals on the whole are less reactive than group 1 and 2, and they tend to be found in their pure elemental form in nature, such as gold. So some of them are very unreactive, and we can find them in their elemental form, so not in oxides. More reactive metals we tend to always find in oxides, iron ores, bauxite, those kinds of things. So if we look at the different metals, what we can see is that group 1 will react vigorously with water to produce a lot of energy, which increases as we go down the group. So sodium will react vigorously, potassium tends to react more violently, rubidium will start to explode violently as soon as it hits water. When we get into group 2, we don't actually see it react with water at room temperature, but if we were to heat up that water, magnesium will react quite vigorously with steam. And then calcium reacts slowly with water at room temperature, remembering that calcium will be a bit more reactive than magnesium because it's further down the group in group 2. It's in period 4 rather than period 3. When we place metals into acids, we can see their changes in reactivity as well. The reactivity of metals and acids will generally greater than that with water. And if you remember, if we add a metal plus an acid, and that's a reactive metal plus an acid, we start to get hydrogen gas, okay, and water. Well, sorry, salt and hydrogen gas. Okay, so if we add zinc with HCl, we will get zinc chloride and hydrogen gas. And of course that will take 2 lots of HCl to balance out to give us the appropriate balanced equation. So a greater number of metals will react with acids than water, and by comparing their relative reactivities of metals, it's possible to create what we call a reactivity series. So a reactivity series lists metals from the least reactive to the most reactive, like a periodic table this gives us a tool that we can use to help predict how things go. If we have a look, this is a reactivity series here. This one is actually listed from the most reactive to the least, and you can see here platinum, gold and silver, which are all metals we prize for jewelry, are very unreactive. Same with copper. Then when we compare these to hydrogen, we start to get things like lead, iron, zinc, aluminium, magnesium, calcium, sodium and potassium. You can see even right down to here with aluminium, we use aluminium in our everyday. But if you have like an aluminium railing or an aluminium window at home, you might have noticed how it gets a white dusty powdery coating on it, and that's the aluminium reacting with the oxygen in the air to form aluminium oxide, so essentially rusting. So magnesium, iron and copper with HCl is what we are seeing in this picture here. You can see that the magnesium here, we have steam forming, we know it's getting very hot, and we can see that the bubbles are forming very, very quickly. So we have fast formation of bubbles. And those bubbles, of course, are going to be the hydrogen gas being given off as the reaction proceeds very quickly. And then with iron, we can see we've got a small amount of bubbles. So we can see that this reaction is occurring, but it's occurring much slower than it did with the magnesium. And then in the copper, we can see there is some tiny little bubbles in the bottom there, but not very many in all. And we can see that this relates to our reactivity series, where magnesium is the most reactive, then we have iron, and then we have copper all the way down here. And so those observations meet with the expectations that we would have from the reactivity series. So when we react with oxygen, okay, we are forming oxides, okay. Most metals will be found as ores and oxides in the Earth's crust because there's so much oxygen around. Some, like gold, silver and platinum, as we mentioned, can be found as their pure metals. So this generally, the oxides form because they are reacting with water and oxygen in the atmosphere. Most metals that we find and use in society are mined as oxides, and then we refine them and purify them in order to make the metal ingots that are then used in industry. So the metal oxides can be processed to obtain the pure metal, and we don't need to do that with things like gold and platinum. This one here is copper ore. We've got some silver and some gold here as well. So as we said, because most metals are found combined with non-metal elements and oxygen, these ores are then processed. So the definition of an ore is a type of rock that contains minerals with important elements, including metals. Okay, so this is iron ore here. We can see this is what is smelted into iron, and then iron alloys are formed to make steel, and then aluminium ore here is bauxite. We have a lot of aluminium ore in Australia. In fact, it's mined quite extensively up in Queensland. Okay, so I'm going to leave this video here. So this is our video on metal reactivity and ores. You should be able to use the metal reactivity series. I highly recommend you put one of those in your notes and be able to describe the observations that we would have for the different metals and how they would react. So the more reactive the metal, the more vigorous the bubbling. For group 1 and group 2, we also have that aspect of the violent reaction and the heat given off from it causing the spark for the gas to ignite, and the more reactive, the larger the explosion that we see. In the next video, we'll look at how we modify metals using alloys and heat treatments in order to alter their properties. And I'll see you in class.